So System View is a company that started essentially to solve the problem of system integration, right? So the embedded systems are getting increasingly complex. What we did was we took Vivado's graphical user interface and we sort of enhanced it to make it a system level tool rather than just being a tool for creating designs for a single chip. All these embedded systems have multiple threads going on today. So what we do in the runtime is provide you a way of easily managing these threads. That was one of the goals of our tool, to sort of enable both the software developers as well as the hardware developers so they can work and create these complex heterogeneous systems very easily. We are going to see today is a 3-axis robotic arm that is being controlled by Zinc. All the software is running on Zinc. It has been developed using our tool, but it's running a real-time Linux, and we use the fabric for I/Os. That is one of the biggest advantages of Zinc. So we have multiple threads that are running on the ARM processor that is communicating with the fabric to control the I/Os, to control the robotic arm. So that's, there is an industrial revolution that is kind of going on with robotics these days. And I think Xilinx are perfectly suited for these kinds of applications, right? Where you need I/Os and compute close to I/Os. So what we're going to see today is a cobot. This is becoming more and more prevalent in the industry, where a human being actually trains the robot to do a particular task and then makes the robot repeatedly do the same task over and over again. Now this button we use for memorizing. So if you press this button, the memorizing will start and it will tell you the memorization is started. Memorize is on, and then we program the movements, and then we say memorize off. Then we can press this button to make it repeat the action over and over again. So assembly lines today, can get fairly complex, and sometimes there are not enough training points for the robot to be trained, right? So the human beings can come and actually do the work essentially with the robot once, and then make the robot repeat that, especially in the assembly line arena. We see this evolving using a camera where you can do the training offline using gestures or vision, or even perhaps a touchpad, and then using machine learning to understand what the human is trying to say, to generate the coordinates, and then put it in a factory environment, and then it can recognize and do the tasks. We are going to evolve this using the same chip, using the same Xilinx chips and the same software stack, using our tool to program it using machine learning or using vision in the future.